Welcome, everyone. The event is now live. John, please take it away.
Thanks, Allison. Hi, everyone. Welcome to today's live Tech Talk. AI meets chaos, automating failure testing and scalable reliability. This event was organized by the hardworking team at Pure AI, and it's sponsored by Harness, provider of an end-to-end software delivery platform that helps engineering teams achieve the highest levels of excellence. I'm John K. Waters, editor-in-chief of the Converge 360 Group of 1105 Media, and I'm joined today by chaos engineering expert Matt Schillerstrom. Hi, Matt.
Hey, John. Thanks for having me on Pure AI. I appreciate it.
Good to see you, man. So I want to tell the folks a little bit about you. Matt is an engineer with years of experience building reliable software and managing high-performance teams. Before coming to Harness, he launched the world's first failure as a service product at a SaaS startup. Now, as Harness's director of product management and marketing, he helps developers ship reliable code globally and to embrace failure as part of innovation. I love that. I'm looking forward to this conversation, my friend. But before we get started, I've got just a little bit of housekeeping to do. This Tech Talk is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. Our sponsor has provided some extra resources you won't want to miss. They're available now in your console. And at the end of the conversation, we'll have a 5 to 10 minute Q&A. Please type your questions into the Q&A box at any time. We'll do our very best to get to all of them. Now I'm going to just set the stage for our conversation today, Matt. As production environments become increasingly complex, traditional observability and testing methods are inadequate for detecting latent failures. Chaos engineering, a discipline that assesses a system's resilience by deliberately introducing controlled failures, reveals vulnerabilities before they affect users. However, many teams face challenges in experiment design, prioritization, and operational integration. I'll be talking with Matt about how generative AI can augment chaos engineering workflows, enabling faster root cause identification, intelligent experiment selection, and more efficient feedback loops. We'll also discuss how Harness is leveraging artificial intelligence and machine learning techniques to drive decision automation, reduce toil, and align chaos practices with real-world reliability objectives. Okay, I'd like to start things simple. What does chaos engineering mean? And today compared with when it was, I understand it was originated by Netflix in 2010, with their Cloud Monkey tool. What is it today?
Yeah. So when Netflix kicked things off, some like 15 years ago now, right? Chaos engineering was about how your system could survive random failure, like yanking out a server, like a power cord or network cord, and then seeing if anybody noticed, right? And it was gutsy and like honestly kind of beautiful in its simplicity. There's a little chaos in my background right now, but I'm going to talk over it. Let me know if construction season, I guess. But the Chaos Monkey tool, killing a server, unplugging a server randomly during business hours to test the resilience of the system, as well as testing the human behind it to see if they could see the server failing, see if they could restart it, respawn. It was really beautiful, right? And today, chaos engineering has evolved into something much more mature. It's not just about breaking the stuff. It's about testing your assumptions before the users are even impacted, right? And today, we're injecting almost surgical tests in a very data-informed way, often with guardrails now, not just randomness, right? So I like to say it's less about firefighting, and today it's more about fireproofing, your system and your human and the team behind it.
Okay, so you say chaos engineering is becoming or has become more mature. How is it becoming more relevant now, especially with AI-intensive systems?
Yeah, I have a slide for that I'm going to push to the screen. And let me know if you see a beautiful green slide now, some things. But I would say, right, vibe coding is definitely increasing the relevancy of this, right? As you are more creative and test things, AI systems are going to break differently than the systems that you created before, right? And what we're seeing is like the AI systems don't always crash, they drift or hallucinate or even behave inconsistently. To be honest, like these new AI systems that are getting built with all the agents, like I haven't even fully like understood how we even monitor all of that today, right? Like I know how to monitor monolithic systems, microservice systems, but agents, I've been thinking about that lately and how you have to do it differently. And that's the thing, right? So like traditional monitoring doesn't like catch these nuances, right? So you need chaos engineering tests to simulate these pressures on the system, these edge cases of failure, and just like what happens like before, like when latency or a network outage happens with an API talking to a database, I know how to handle that, right? Like with retry logic. But when agents like or AI systems break, like a lot of them too, like are their own thing. So how do you signal to them to stop doing something or retry? And there's ways to do it, but it's just so relevant now just because there's new ways that things are working and breaking, if that makes sense.
So what's the biggest misconception about chaos engineering or chaos testing?
Yeah, what I would say, like, biggest misconception is like people think they have to start in production. When I talk to customers, a lot of times they're already like, well, I have enough chaos in production, so I don't need to practice chaos engineering because my environment is already chaotic, right? But you should know you never have to start in production, right? It's always better to start in lower environments, just like you would do with any sort of like code push from, QA, staging, pre-production, production. So you always start lower and work your way up, right? And the big myth I would say is chaos testing is only for like Kubernetes wizards or site reliability engineering teams and tech unicorns. And that's really not the case anymore. Like if you as an engineer, product manager, system owner are dealing with dependencies, third-party APIs, or even auto-scaling procedures, congratulations, because you are already like in chaos and you just need to test it, right? So that's kind of the biggest misconception is just like you have to start in production and you have to be an expert or at a startup like Netflix to do it, but no, like you can practice it anytime that you have a system that you're supporting.
Okay, so what about the most common hurdles teams face when trying to implement chaos engineering? Maybe talk about that for a little bit.
Yeah, so what I would say honestly is like the whole analysis paralysis. Teams don't know what to test, or they worry about breaking things, right? They don't want to cause an incident, but they're happy to wait for an incident to happen unexpectedly in the future, right? There's also like hurdles of like lack of time. Like product management isn't setting aside time for their engineers to test and validate, right? Maybe they're doing unit testing or some other simple things, but they're not proactively testing for that failure from an incident. I would also say a lot of people that I see, they try to build this whole framework from scratch on how to test, where to test, and they'll just spend months and months and months thinking about it, planning it, and getting buy-in. But honestly, you can start with just one test, just like that chaos monkey test that we were talking about before, and that reveals a whole bunch of issues, or it validates everything that you put in your code or infrastructure that makes your system resilient. So the whole goal is, make things relevant with this testing, not random. And analysis paralysis is like the biggest hurdle I see.
Okay, I hope this isn't a weird question, but how do you handle the fear factor of injecting failure into production systems?
Yeah, what I would say with the fear factor, like you earn trust like incrementally with everything. So when I used to work at Target.com for 4 or 5 years, and we built out our chaos engineering program there. And we didn't just jump in and do a first test. We went to like a sprint planning meeting or a demo meeting with our team, and we kind of talked about chaos engineering and what it was and what you could learn. Because honestly, there's a lot of things you can learn about your system by just like passively talk or like by actively talking about it versus like injecting failure. So there's the incremental step approach of, crawl, walk, run with chaos engineering, where you're talking about it. Can I monitor and observe my system? Then I'm going to test it and validate it. So that's kind of usually how you handle that and stuff. So
why do so many teams struggle with prioritizing which chaos experiments to run first?
Yeah, I mean, I think today, there's so many memes about this out there, but everything feels important. Like everything is urgent. You show up every day and there's just like new things to figure out. And when everything's feeling important and your manager and product manager don't like help you guide through that as a developer, it's stressful, right? And and when you look at like your infrastructure and applications, like everything might feel like spaghetti.
Yeah.
But honestly, how you prioritize it is just like, taking an incident that just happened and talking to your team about like, hey, let's proactively test for this so we don't have to get woken up at 2:00 in the morning and respond to it, right? Let's understand this failure mode and then work through a list of other failure modes that might exist so that we don't ever have to like respond to that. Like we can be proactive and almost predictive with that. Yeah.
Okay. Shall we get to the AI of it all? And my first question is, how exactly does AI help identify failure points faster than traditional methods?
Yeah, I got a few other slides for people to look at too. What's interesting with this slide that I have, so it's labeled like how harness AI works. But you could imagine like any company building their architecture like this. But we've had AI since the beginning of our product, but now like we're building agents for everything. Whether it's a chaos reliability agent or a site reliability agent or a deployment agent or something for feature flags even. But as you can imagine, with the whole software delivery lifecycle, there's a lot of data and understanding. And some companies have roles where maybe there's a delivery manager who knows a lot about what's happening. But now that context and data can be within your whole software delivery lifecycle, such that these agents can know. So what's important, like AI can excel at the pattern matching and connecting dots across the telemetry that humans would never correlate, right? You still want humans in the loop for understanding, and that's where AI can teach. But now, like AI and these systems can say, like, hey, service A and service B keep failing after these deployments, right? So then you can identify these weak spots, and then through chaos engineering, it can recommend tests to proactively identify that pattern, right? So it's like having a site reliability engineer, like who never sleeps and maybe reads every log line, but at your disposal as a human to learn from, see, and make things better. So it kind of all around the data of everything.
Well, my next question, can you explain how Gen AI is used to suggest or even auto-create chaos experiments? I mean, just say more about that.
Yeah. So I'll push one other slide too for a little backdrop on everything.
Reality agent.
Yeah, that's a reliability agent too, but reality. That's a really good marketing term. This is the reality of things for chaos engineering. So yeah, this is where it gets pretty fun, right? So Gen AI can take all this data and look at your system topology, recent changes, past incidents, and say, here are 3 chaos experiments to validate your system behavior. And then it'll describe each test, how to measure it, what's successful. And then ultimately it's trained on past runs and behaviors. So it's like always in this constant state of learning, such that your engineers don't have to start with like a blank slate of everything. Because oftentimes, like I had said before, like where do I even start? When I used to work at Target, I would always say like start slow, but don't be slow to start. Meaning, like do something, take action, right? Do one thing, right? And this is where like Gen AI can help people understand as well as execute, especially if they don't know where to start and have analysis paralysis. So.
Okay, how does AI assist in reducing the operational overhead, what we're calling toil, for SREs and platform teams?
Yeah, great question again. So kind of relating back to what I was describing before, but before AI, someone would have to like write the experiment, schedule it, run it, observe the results, and file a JIRA ticket for fun as well, right? Because there's always documentations or approval. And a lot of these tests might be complicated scripts, or if you think about spiking CPU on a server or memory, maybe you're writing some sort of algorithm to like exhaust the resources in your server. But you don't have to do that today with any chaos tool you use can implement those. But then where AI can help with that today, right, is writing the experiment, scheduling it, prompting you when to run it proactively, or even in some interesting cases too, like the data that it consume across Kubernetes configurations and the services and like monitoring tools. Maybe you don't even have to run a chaos test to learn, right? You've probably heard of like linting your system and like all this passive stuff. But there's a point where if you look at a config file and some monitoring and logs, you can almost predict how it's going to happen. And like a side story on this. So back when I worked at a nuclear power plant for 13 years, in between like my IT jobs, I was actually a predictive maintenance engineer. So I did testing on all the pumps and motors and stuff that operated the nuclear power plant. And we did predictive maintenance to anticipate how the systems might fail, whether that was like vibration analysis to understand if the bearings in the motor were getting worse or whatnot. But I always, when I did that for 4 years, I'm like, why did I do this? Like, this is not relevant to my computer science degree. But it always comes back to like the reliability framework and methods and like that analysis problem solving skills that I learned, like still apply today, even to this conversation. And I see Gen AI helping out with this predictive analysis within chaos engineering here in the near future as well. The reality agent is today, for the reliability.
Right. Well, not much at stake there, huh?
Yeah.
Do you have any real world examples where AI driven chaos testing revealed something that the manual testing didn't?
Yeah, I think a couple of simple things. So like right now, like it has definitely helped teams onboard, start, and scale. Like once you get that like to-do list of tasks you need to run based upon AI recommendations, like people are confident that this is the right test. The tools will tell you what the test means, just so you're not running it blind. Like I've been practicing chaos engineering for quite some time, so I usually just know what's going to happen. But if you're a new engineer, like you don't know what injecting 1 second of latency is going to happen, right? So the system can actually like teach, train, educate, which is great. And that's what we're seeing now, right? With that, there's all this like AI magic, but what I love the most is just like it's teaching and making it more accessible to everybody so that we can share that knowledge. And then also just some interesting things too, right? Like if, so for example, like rollbacks. So like with CI/CD and continuous delivery, rollbacks are important because if you deploy a bad image or an application that's consuming too many like memory like resources, you want to roll that back. But now with AI and especially monitoring, it can get more predictable, so you can see that ahead of time and then roll back. And that's where like chaos engineering is helpful, because before you deploy a new image or application, you can run it through a bunch of tests, like a gauntlet, like a battering ram. And then rather than waiting for an incident to reveal itself in 2, 3 weeks, 4 weeks, right? You're creating that incident right before deploying it to validate the system has its integrity. And then you can roll it back before it ever goes to production, right? So all these things are possible because of that. And it's just making it easier now.
So your company has a chaos engineering platform. Maybe talk a little bit about how Harness's platform supports. I've got multilingual environment testing from staging to production. By the way,
yeah,
I got a leaf blower out here too, so the chaos is everywhere.
I know. Thank you for all the patience for all the people listening to me and the background as well. Appreciate that. So multi-environment testing. So similar, like I was saying before, how you promote code through production. That's how we like to think about testing as well. So never starting in production, but obviously lower environments, and then graduating and promoting. The one thing that's nice about our platform is usually like how people do chaos before they come to us is they're running scripts or manual testing in kind of an uncontrolled way, right? Like they have elevated permissions and security rights to do things as you would want, because if you're restarting a server, killing something like a process, you need elevated rights. But these humans and engineers maybe are requesting access to the system, running something manually, observing it manually, and then completing it, and then maybe like removing their security rights, all that kind of stuff. But now people on our system, right, like we can orchestrate all that in a configuration file in a pipeline. So there's that end-to-end test. And it's not just about like the fault injection or the failure. Like we have a pipeline where you can create a JIRA ticket, get an approval for the JIRA ticket, kick off a load test, monitor the system, run the test, like the failure, and then close the ticket even, right? So all the boring stuff of running any sort of test, we can automate for you, so that maybe it takes a while the first time you set it up, but then after that, it's this repeatable template with governance and security, and you can just expect it to work. And that's what's really great, is because AI is making us all run really fast and hopefully not into brick walls. But these templates and everything that we create can help you have that consistent format for testing, right?
Okay, so Microsoft's Satya Nadella welcomed us all into the agentic world recently. I'm wondering what role agentic workflows play in the user experience for reliability testing.
Yeah, so I love that as well. It's interesting to think about agents and workflows. This past week, I was on the phone with a lot of doctors' offices, waiting, scheduling, having conversations, and I'm like, I wish I could just have an agent to do all that for me, But if you think about it with like chaos engineering too, like I want an agent to do all the boring stuff, like I was talking to you about, like with JIRA tickets and all that kind of stuff. Right. And I want to do all the hard stuff too, just so I can work on better things. So what we're seeing that with the user experience is, rather than users clicking around to trigger tests or analyze data, like we're having AI agents that can do that for you based upon the guardrails that the human sets up too. But besides like recommending tests and running them and summarizing the results, it's kind of like you're managing like a team of assistants in the future here, right? And you could imagine too, like I don't know if trust is a good word, but if we trust how we program the agent, maybe that's a good word. Like then we can empower it to run these tests automatically. Like teams are already like scheduling tests automatically or automatically deploying code and doing testing, but you could imagine these AI agents, when they see your environment, certain triggers, like it happens. And like auto scaling is kind of like this. Like we trust auto scaling procedures to spin up our environment bigger to support more customers hitting our website. And that's procedural stuff. But then as AI gets more involved with these resilience mechanisms, like we can empower it to do these checks and tests. And that's honestly where chaos engineering is going to become so important, where you're doing proactive testing on your AI workflows and the agents, just so that they're working when they're supposed to work, and then you know how to fix it when it breaks. So it's going to change the whole experience for the better, but it'll take some time.
Okay, can you walk us through how the system suggests tests based on recent incidents or changes in production?
Yes. I have another slide I'm going to share. Let's see. Here we go. Push that through. So this question, I'll probably use this for a few questions related all together. But like I was saying before, like the platform can look at deployments, config updates, flag toggles, anything that's happening in your environment, especially things that are very boring, because incidents often start as something boring. But then as we see anything that's risky, it's almost like it's a chaos blame radar detector, if that makes sense, that's always running, and it can point and infer things. So anytime like something changes, that's usually when there's an issue, especially like when I worked at the power plant, very mechanical, right? And anytime there was like an outage or a drop in power, there was some change that you'd always go hunt down. And the same with with systems today, like a change will cause an issue. And usually we're really good at seeing big changes today, but it's the small changes that happen that combine and trickle into something bigger. So that's where these agents and monitoring tools, right, can help us see all these little things that are going to eventually point to something bigger.
Okay, to be clear, does the platform learn from past incidents to improve future test recommendations?
Yeah, so that's where we're at today, is taking past incidents and learning from that. And what's interesting about that too is we always want to if you're a bank and you have incidents, you often don't want to share that. So how are we protecting the data, isolating it your own version, running stuff locally and inferring. But what's great about all this too is it sounds fancy, right? Like AI is going to go look at all your incidents and recommend things. So what I'll tell you, last year, we partner with so many banks, and one of the banks gave me all of their incidents to analyze with them to understand the root cause, if you want to call it that. And honestly, they all kind of themed into just a couple of different areas, so hundreds of things theme into certain tests. And at the end of the day, like a chaos monkey test or adding latency into your system or exhausting resources, check the box for almost every incident that happens, So what I'm getting at is we can get super complex with all this, and AI can do all these great things too. But with chaos engineering, if you just start with 1, 2, 3 tests, it almost, covers 80% of what you should really care about. But yeah, to answer the question, we can take that data, learn from it, and empower the future and make it better.
So how do you recommend teams align chaos experiments with business risk or SLAs?
Yeah, great question. So not every company has service level agreements or service level objectives or that kind of a thing. But let's imagine you do, right? But I would just start mapping your services to those service level agreements or measurement goals that you care about. And for example, I would say everybody has a login service, to get into your SaaS application or tool. But so you might just say okay, I expect my login service to have a 99.99% uptime, right? So 4 nines. So then you just start asking questions like, what happens if Redis fails, or what happens if this server can't cache the logins? And then basically you're aligning it to the risk associated with that service and the business goal that you have. And then you just start testing against that and map it to that. So then ultimately, like if you run these tests and that number degrades, that's a signal to go look into it and everything. And as a product manager today, and especially when I was at Target as a product manager, like there was KPIs and business things that we were always looking at for Target.com, which was always around like sales and revenue, right? So we always kind of mapped to those metrics for uptime. Like we always looked at like the average size of a shopping cart, and if that was hovering less than like $50 for every cart, for example, that's a signal for us that something is breaking and going wrong. Like people can't check out or add, or search isn't working. So like we always looked at business metrics that people cared about and then ran tests against that. And if you, like the CEO of Target cares about shopping cart size in the Target.com bucket. So like you find metrics that people care about and you test against that.
So is there a framework or methodology you suggest for balancing the breadth of coverage with test frequency?
Yeah. So one like example I like to give for various things is if you think of it like a pyramid of testing. So like at the base of a pyramid, you have like broad, low risk tests, like pod restarts, server failures, CPU stress. And then like the middle is around testing dependencies. So again, like the bottom layer is like, is my server healthy? Is it doing its thing? Second layer is around dependency, where it's sort of like, are the things I rely on doing what it needs? And like at the top is like high level, high risk tests, such as like cloud provider outages, perhaps, right? So things maybe out of my control, or things that I have to spend a lot of money on to be redundant. Target.com, when I was there, we were in on-premises and multi-cloud environments just because it was that important, right? But I recognize some businesses, can't be that redundant and built. So it's all about managing the risk on those layers, as well as being fiscally responsible with what you build as an engineer for the business.
Speaking of management, I have an age-old question here. How do you convince leadership that chaos engineering is a strategic investment, not a risky experiment?
So I used to be an IT, yeah. So I used to be like an IT disaster recovery engineer and like a business continuity person with that. And they always looked at us as like a cost center, which isn't entirely wrong. But I always tried to tie it back to dollars and like saving cost, right? Because when I was a disaster recovery engineer, sure, it was a cost center, but at the end of the day, you're protecting the company and the business from a huge risk of like a data center failure, right? So I was always tying what I was doing to dollars. Downtime equals money, and your board, your shareholders, your stakeholders care about money. So I would show them, in this case specific about like chaos engineering, like when we found something, we'd be like, hey, we caught this potential outage in staging before it hit production, right? So caught this huge issue before it got pushed to customers, and then kind of draw out that story a little bit more to say like the impact, the cost, what this would have looked at. And I like marketing things. I'm a product manager and a product marketer, so I always like feeding into the story, telling that story, just so people don't forget about it. Because one of the reasons why like a chaos engineering program will die on the vine is people run these tests and they don't talk about it. They don't celebrate the wins or the silent successes that happen. And that's really what you need to do. You have to market, your program. So.
Smart. Okay, so AI is evolving at warp speed. Where do you see chaos engineering evolving as AI systems become more autonomous and critical?
Yeah, so kind of like what I was saying before, it's becoming less of like breaking things manually and more about like validating your assumptions continuously, especially at the frequency of things changing. It's hard to understand all of that, right? So in the world of AI, systems are complex and it's not like this linear understanding. It's exponential in every which way. So we'll need to like automate the fault testing, fault injection, chaos engineering constantly under these dynamic conditions. So how I see it, right? AI won't just like run these applications. It'll need to test itself, right? As the system changes and everything. So it'll be more, self-aware of the system and more tests, in response from that.
So do you think AI will eventually run chaos experiments autonomously based on real-time signals?
Yeah, I think we're absolutely there, or halfway there maybe. Like people, schedule tests or automate tests in deployment pipelines. But yeah, I think the next evolution is around like the autonomous loops. Like the term feedback loop is always like people talk about that with your system. So I think that's where like the system might degrade. We run a test, we learn from it, we confirm the behavior of how the system's working, all in real time with guidance and control from us as humans. But yeah, I think it's going to be kind of like my Chaos Monkey story before from Netflix, but continuous and driven through AI. Granted, like I was always telling you though before, if you just do a couple of tests consistently, just like, drinking water is good for you. Like if you do a couple of tests, even without AI, like you're in a good spot. But I think that's where the evolution is heading for that autonomous testing and everything.
So interesting. Okay, final question for you from me. If someone listening today and wants to run their first AI-assisted chaos experiment tomorrow, what's the first step?
Yeah, so I mean, start with like a known risk. Pick one service that had an incident last month, last week, and you without a tool, like you can use like your favorite like ChatGPT or whatnot to even just like ask like, how do I test this risk or how do I test this incident, right? And then you can run a test based on that. Otherwise, like what I would say too, even where I work at Harness, like we always have a free version with some limitations on testing. But you could use our product or another product, run it in staging in a lower environment. Don't start in production, and just start. Measure it, repeat, and then kind of like talk about it with your peers, right? Just to kind of share the learning. So yeah, just start with your first failure under controlled process, and the rest will follow. So
Here's to failure. Okay, that's all the questions I have. Let's get to some questions from our attendees. Remember, guys, you can type your questions into the Q&A box at any time. We'll do our very best to get to all of them. Let's start with this question from Al, who's wondering, Matt, how has your experience in nuclear and retail influenced your approach to chaos engineering today? That's quite a wide range of enterprises there, nuclear and retail.
Yeah, I don't know why I have that background, but it's
great.
It's the way the cards folded out. Yeah, it's kind of, I mean, looking back, when I worked at a nuclear power plant for all those years, we didn't do like chaos engineering and everything, but we tested the heck out of our system. It was a very regulated environment. It was very redundant and purpose built for failure. And if you were to take a tour with me of the power plant, and asked me what everything did, I would just tell you it would be to safely shut down the system in the event of an emergency happening. So the background in nuclear always gave me that like architectural mindset to like build things the right way. At a cost, obviously nuclear power, like building that is costly. The fuel's cheap though. But yeah, so I apply that, when I'm building and architecting systems. And the retail side of things, like I learned how to build like high performing systems at demand at peak periods for selling things, right? Before I was selling energy, but it was kind of like down the power line, like it was fine. But with retail, all the systems I worked on, it would definitely impact the bottom dollar of the share for the customer. So the mindset of, regulation, the mindset of like, how do I build revenue, influenced me on like building a product for chaos engineering that can be used by a bank in in a highly regulated area, to like a retail environment that wants to use a chaos tool just for quick testing, scheduled and planned, but more just sporadic and everything. So, yeah.
Okay, here's one from Perry, who's wondering if a company has limited observability or no SLOs in place yet, can they still benefit from chaos testing?
Yeah, so my answer is yes. And just to explain that a little bit, like there are some people that say like if you can't observe it, then you shouldn't do any testing, which I totally get. Like you should be able to see and view the impact to your test. But if you start slow and small, and just have some monitoring in place, whether it's logs or just even simple like, is my system up or down, right? That's a good way to test, especially in a lower environment. And again, people always think chaos engineering and observability and traceability are for unicorn type tech companies. But at the end of the day, a lot of people with testing, especially in lower environments, they're just like, is my system up or down after I run this test? Like when you unplug a cable, my system is down, that's obvious. But as you start doing other smaller type testing, it's still a good signal. Like, is my system up? Is it down?
Okay, this is one from another one from Perry, who's wondering, how do you measure the success of a chaos engineering program beyond just running tests?
Yeah, so part of this is around like the marketing idea that I was talking about before too. Like I measured success previously in my career at Target around like metrics, like mean time to respond, mean time to identify, mean time to detect. Those kind of metrics, if you like them. There's some people that don't like those metrics for sure. Some of my success from those programs were just around like, we built out like today in our product at Harness, we have a coverage map of everything. So you get a resilience score. So is that resilience score increasing or decreasing? Another signal that we'd always get too is like less incidents, right? Or like team dynamics are better because people are learning the system and knowing the system. But otherwise, like a measure of success, like I said, like is around, those metrics I mentioned, or availability, incidents, or just honestly, like I would just go talk to the team manager after we did these testing and be like, how's your team doing? Are they talking more about these incidents? Are there less incidents? Is on-call still stressful or not? Which I love because that's keeping the human in the loop of the conversation. Like you're not just looking at a metric, you're actually having a conversation with somebody to see how it's going.
So we've got one, looks like we've got time for one more. This is from Sunny, who's wondering, Matt, what excites you most about where chaos engineering is heading in the next 2 to 3 years?
Yeah, I mean, I think finally we're at a point where everybody's going to know what this is and they're going to be able to do it, right? And I think it's going to be more accessible for everyone, right? Easier to do, and everybody can learn from it. So that's what I'm honestly excited about. Like some people might say, we're going to be able to automate everything away, which sure, that could happen. But I do think there's still, with everybody having it be more accessible, knowing what it is and understanding, like people are going to learn so much about their system. And I always kind of quote there's a podcast that I listen to about a guy, he's actually a minister, but he always talks about, like, if you don't know how something is working when it's working, like how are you ever going to know how to fix it when it breaks? So my whole goal with all this is like helping people learn how the system is working, behaving, such that when it breaks, they know how to fix it because they know how it's supposed to work. So that's what I'm most excited about.
Well, that's all the time we have for this Tech Talk. I want to thank Matt Schillerstrom for an informative conversation. Many thanks, Matt. It was really nice talking with you. And also thanks to the folks at Harness for making this conversation possible. Thanks, everybody, and have a great day.